but let's jump in with great enthusiasm. And as I said, any problems, you will get the recordings, so don't fret about that. And Carol, if you can text if anything happens. Carol's in our London office, I'm in Perth. And what I want to do is do two things here. Briefly, in 30 minutes, a very, very fast whistle-stop tour. Quickly go through PLC programming, the basics, and then jump into, with great enthusiasm, into systems programming. In other words, going one step further. So a little bit ambitious in 30 minutes, but I'm sure we can do something. So we do these, it's presented by me, Steve Mackay. We do these every week or 2 weeks, and once a month we do a live session. So just briefly talk about key elements of Ladderlogic, and then look at simple programs, and then just talk about design, troubleshooting of a PLC program. So hopefully everyone hang in there, and as I say, let's go for it. Okay, so fundamentals of PLC programming. Just want to briefly talk about introduction, and I will come back to you guys just to make sure that you can still hear me. As I say, all recordings will be given to you guys. So first of all, obviously you need a programming terminal, and obviously something like this, programming terminal, and your good old PLC. And as you know from those that are experts here with PLCs, you obviously need the processor unit, communications, I/O, and then obviously the power supply. And in fact, some people get a little bit irritated with reliability of PLCs, and often forget to, they often neglect the actual power supply. So it's obviously very important. So briefly talk about different languages. And there's a whole lot of different languages. I don't know if any of you heard about the 61131-3 standard. Has anyone here heard about the 61131-3 standard? It's sort of an attempt to unify PLC programming. Keith, Gerard, yeah, I think there's an issue with the slides with NASA. I suspect he's on a browser, so it's probably a problem. Does everyone see the programming software laid out there as the head slide? No, okay, and often as well. Okay, look, don't worry. You will get a copy of the slides and the all the listings, so hang in there. Often. So basically what we're going to talk about is PLC programming steps using the 61131-3 standard. Okay, so you can't get the slides. Okay, it's another problem here. Keith, are you using a browser at all? Can you just tell me if you're using a browser? Using a browser. Yeah, okay. I think some of the browsers there's a potential problem with the slides still. Google Chrome, okay, that's odd. Google Chrome. Okay, I'll tell you what, often Keith and Gerard, if you can't see the slides, we will send a set to you. So, Carol, have you got the email addresses? I'll send the slides through to you, the PowerPoints, like we've done before. Carol, are you there?
I've got Keith and I've got Arfin's. I'm just looking to see if I've got NASA. He's just logged out actually. I haven't got Gerard's. I can't see Gerard on my list. So Gerard, if you do you mind putting your email address up, and I can, if Steve sends me his slides through, I will send them on to you, and then you can have a look at them while Steve's doing the presentation.
I'm just going to send the slides through to you now. No, Keith, don't worry. I'm going to send the slides through to you now. Don't waste your time. Time's short here, and the system goes on. So what I'm going to do is to send the slides. Just hang on one tick, Roodle. They will come through. They're very small, but they will come through to you now. So just hang on one tick. I'm just going to grab them. Okay, Carol, I've just shot them off to you. If you don't mind distributing to the guys, I'll talk them through. Thanks. They're quite small, so they'll come through very quickly. No, don't waste time. These sessions are quick, and I'm not going to waste your time. So really, just talking about the 61131-3 standard, that is a prime requisite here. Has everyone heard of the 61131-3 standard? Keith? Gerard? No, okay. This is a standard which you should have. Okay, this is like a C++ programming standard. It's a standard for all PLCs. So the idea is that any reputable manufacturer, and believe me, most manufacturers are jumping in using the 61131-3 standard. So there are different types of programming languages. So you could go from Ladderlogic, which we're all familiar with. You can go from Ladderlogic to function block, to instruction list, to flowcharts. They all are defined by the 61131-3 standard. So it's an attempt to try and unify programming. You will get the slides, so just hang in there. Carol hopefully will be getting them, beavering away there. So you'll get the slides in a tick, so hang in there. Emil guarantees us that all the bugs will be ironed out in the next revision of the HTML browser. Yep, thanks. So just bear in mind this standard is around. You should be able to see me writing on the screen. Just bear this standard in mind. If you ever work with PLCs, always check that you've got this particular standard. Okay, so now we move on to the preparation of the control strategy. Obviously, you first of all need to define your control philosophy, then individual structures, and then you end up with a flow chart of how you're doing the programming. So bear in mind that you've got a choice of different programming languages. Ladder, which is probably the most famous one, Ladderlogic. You could see me scribbling on the whiteboard there. I presume you can see ladder, function block, instruction list, sequential function chart, and structured text. You're very unlikely to see instruction lists these days. Very efficient, but good. Thanks, Keith. Instruction list is extremely efficient, but extremely hard to read later. So bear in mind, whenever you write a programming PLC Ladderlogic program, you need to make sure that it's readable to the guys coming a year or 2 years later. You don't want it written in some gobbledygook assembler type language. So really important. So Carol, can you just confirm you've got the slides by now?
Yes, I've just emailed them to everybody, so you should get them in a minute or two.
Excellent. Okay, so everyone should get the slides. Pull up in PowerPoint. There's a lot of slides there. I'm only going through a few of them to try and make sure you don't get bored out of your brains. You should turn to the slide headed ladder diagram. So if you can just flick to the slides called ladder diagram. Ladder. Thanks, Carol, for stepping into the breach, dear friend. It's an expression. Ladder diagram you should see at the top of the PowerPoint slides. Can you see that yet? Ladder diagram. Okay. Now, in this ladder diagram, all we want to show you is that there's a very simple way of writing a program. This is one of the most important programs, which is a building block of all PLCs. You'll always see this. It's always a test question as well when we set test exams. So the idea here is that you've got a start push button, and all we want to show is that it's a sealed contact. Can you tell me what fail-safe is? That's built into the diagram here. Can you tell me what fail-safe is? Just text it in the box there on the side. Fail-safe. What is the stop push button? It's normally closed. Yeah. Okay. Can you see the slides? Brilliant. Okay. Excellent. Thanks. So what we want to show you there is that when you've got an emergency push button, you obviously want to make sure if the cable's cut or broken, the PLC would immediately trip out the contact. So what we're showing you here is that power flow from left to right. You push the start button. The stop push button is healthy. In other words, it's energized. You're happy. No one has pushed the emergency stop, and then you energize, and then you have a process called sealing the contact, which means that once the contact's in, it will be locked in until you push the stop push button. Very important. So that's an important part of the diagram. So the next diagram, the execution we want to show you is that you go, for the first scan, you go through there, and then the second scan, you will then seal that contact in place. So there's heaps of different logic instructions, and this, you should be able to see these slides headed up basic logic instructions. Logic means on, off, 0 or 1s. So please, I assume everyone has got a set of the slides now. At the top, please flick to basic logic instructions. There's a whole heap of different logic instructions, and probably often the most famous one is examine if closed, examine if open, which is popularized by Rockwell or Alan Bradley. And then output, turn a bit to true or false, which means drive and output on or off. So those are what we often refer to as coils. And then you get one shots as well. So this is a particular examination one here, examine if closed, this particular slide here, EXIC, which basically says check whether there's power coming in other words, digital input on or off. That one says examine if open, which means that if you have de-energized the input to the PLC, there will be power flow through there. And then this is the output. So in other words, remember what we did earlier on. I'll just flick back to those diagrams earlier on. Just flick back a few slides. You should see a diagram, headed ladder diagram. Ladder diagram here, and you'll see that you've got the contacts on the left and you've got your coils on the right. So those are the output instructions. So you've got input, output instructions. So let's press on. Other instructions that you often have are latches. Can you tell me what a latch is? What's a latch output? So here we've got OTL, latch output. Any suggestions? Just text it in the box there. Carol, any suggestions from you? Can you still hear me okay? I haven't broken up and disappeared. Okay. Carol, I'll ask an unfair question. Latching basically means that you set the output on, you latch it, you stick it on, it stays on, and you drive the output on. So in other words, if you're trying to switch on a pump, once you latch the bit on, the output stays on and it drives the output. And it stays on until you unlatch it. So it's quite a good bit to use. One shot, any ideas what a one shot is? If you've got a scan of the PLC of 50 to, well, probably typically 10 milliseconds, a scan, in other words, a complete operation of the PLC, one shot is on for one 20 millisecond scan, okay? Other instructions that you've got are timers, and you have a timer address. So typically timers have timer on and timer off. They're very important PLC instruction, timers. Timer off, basically it means that the timer off is you energize the timer, it's like a clock, and when you take the power off to the timer, it takes time before it switches off. So say maybe you put a minute in your timer, you say 60 seconds, leave it on for 60 seconds. When I switch it off, it'll take 60 seconds before it switches off. So it's a timer off. And timer on is you switch it on and you wait 60 seconds before it switched on. The output goes on. So they're quite important. Counters, the other very important one. If you're counting pulses, you need to use a counter instruction, and you also need a reset because you count up to a particular number. You can count up, count down, so they're all very, very friendly instructions which you can use. Counter up, count down, and you can have counters which count up and down, depends on what you say. Okay. Other instructions which are quite interesting are subroutines, and you'll see subroutines, so you can actually jump around the program. XI, XIC, and XIO. Basically, just think about a input as being, if you've got a contact external in the field, which is 24 volts DC, 24 volts DC input, when it goes on, your instruction in your PLC at bit goes on, and it will then drive, it can then be used to switch other things on. So it's just it just says, examine if it's on, if it's closed. So that's a bit. Jump, I'm not going to worry too much about that. Master control, I'm not worried about. Data is the other thing. You're often going to work with data, and so we've just been speaking about single bits, but you can also work with registers. In other words, 16-bit registers you can work with as well, so that's quite important. So you may want to move a register. So for example, you are measuring the flow rate and you digitize it to 12 bits, 0 to 4095. You may say, if the flow rate is 50%, I want to digitize that value and I want to make a decision. So for example, if the flow goes up to 50%, I want to switch a pump on. So registers are very important, and most analog analog inputs are 12 bits, which means you can break a signal up into 4095 bits. Often you see 16-bit registers as well, 16-bit analog values, which is probably an overkill for most of our applications. Other instructions which you use in PLCs are arithmetic or mathematics, addition, subtraction, very powerful. Say you want to add 2 flow rates coming into your plant, you can add the 2 registers together, very important. Or you may want to subtract. So subtraction is another one. So multiplication is another one. So these are all the standard registers and manipulations that you have on your calculator, all available in the PLC. Other ones which you come across are division, but we're not so worried about that. Now, we've written a short little program, and if you're an electrician, you should be able to write a program, a PLC program. Very easy. You can be taught it in a few minutes. But the next stage is to look at the overall holistic system. So I just want to spend a few minutes talking about the overall system here. This is all contained on your slides, so don't panic. It's all there. And what you're going to do here is take your process inputs, which is take all the inputs to your process and look at what you're supposed to control. So you need to put together equipment lists, instrument lists, abnormal conditions, layout of the PLC, operator stations, process, all the items that you take, you need to think. And then you need to create an I/O list. I/O list is an input-output list. Can you see this list here on your, that you've been sent? It's called creating an I/O list. You'll see a whole lot of items there, local stop, local start, and you'll see the type of input is digital input or digital output. So for example, you could have digital output there, raw mill motor on command. So it's an output to the mill to say, please start up. It's to close the thing. So you create an I list. And the I lists are very important that you use a database program such as Access to actually store all your I/O input outputs. And I've only given you digital inputs, digital outputs, but you could also be looking at analog inputs, analog outputs as well. Then deciding the hardware configuration of the PLC system, which relates to your program. You need to obviously look at the physical layout of the process equipment, the instruments, the type of process, voltage standards. Most PLCs will be standardized at 24 volt DC. You could use 110 volt AC or 240 volt or 230 volt AC, but you're not recommended to use high voltages, mainly because of safety. So 24 volts is a good, comfortable volt. I've used 48 volts in the past, but today, typically 24 volts saves you power, and no one gets electrocuted if they touch your card by mistake. Other issues which I haven't dealt on here, but we will do in future, is the communication between the PLCs and your thing. You need to look at that. TCP/IP, Ethernet, control logics, all these are communication standards. Look at future expansion of your PLC. Always leave, in your PLC rack, always leave about 20% space. In other words, you can put 20% extra I/O in the future. So try and ensure you can handle more inputs, outputs, both analog and digital, in the future. And there's also space for expansion. Very important. You don't want to be locked into, you've got 1,000 inputs and that's it. We cannot expand any further, because guaranteed there will be changes. And then the other final point is look at your spares, very important. So the hardware configuration, we've got a whole lot of slides here about hardware configuration. You often set up the dip switches for the I/O, or you can do it in software these days as well. And it's just a process there. So my final thing here is just to summarize it all, to avoid any potential blaming because Steve has spoken too long. I'm just going to ask any questions at this point. Any questions? And just to come back to that earlier question, Gerard said, can you please explain XIS? If you look at this little ladder diagram here, this is a simplest possible ladder diagram that you can ever get. You should be able to see it there. Let me just change my color to red. So basically this says, this one here is an input, and basically when it goes on in the field, you push a switch on, there's power flow from there through, and it then energizes this thing here called a coil, and then that drives that output on, switch pump on. So that's the coil, and often we have a thing called, which we try to show you in a diagram, that's what it's going to show you here. Often we have a thing called a sealing contact, which means as soon as this power flows through there, and that bit there is, say, number 1, and this bit's called number 1, then on the second scan coming through the PLC, this bit will be locked in as on, and the power flow will be there forever. So what we've got to do is put another thing there, which is your emergency push button stop, or a stop switch. That's really about it. Any questions at this point, please text them in the box. And Carol, over to you. Any questions?
No questions from me, Steve. Has anybody else got any comments at all about the presentation, or as Steve said, any questions? If not, we'll wrap the session up.
Yeah, look, we will be going into more depth on PLC programming with some examples in the future sessions, but all we want to do now is just say to you, look, there's a whole heap of instructions, digital input, digital output instructions, power flow, which energizes a coil, and then once you've got the PLC programming understood, you then need to move on to the understanding of the complete system. In other words, the, should we say, the holistic view of the system. So you look at the hardware, the power supply, et cetera, et cetera. So things like, which you may think are irrelevant, like 24 volts supply you need to standardize on. You need to make sure your supplier is obviously going to supply PLC input outputs of 24 volt DC. And then you also need to plan for things such as spare capacity in your PLC rack, so you can actually handle the increase in the future. So these are all sort of issues which we're going to delve with into greater detail in the future. So once again, thank you very much. I'm sorry those of you couldn't see the slides in the browser, but we've almost got the browser sorted out. We've got a problem of compatibility between the Chrome, Google browser, and the Internet Explorer, which has been bedeviling us for the last 3 months. But Emil has got a solution, and he's about to implement it in the next few days. So we will have guaranteed browser compatibility with all the browsers and our standard Lectromeet system. Much to Carol's relief, because it is a nightmare having to send out slides and irritate people by not seeing the slides on the screen. But you will have full audio and compatibility on the screens with your browser by the next time we run this thing, guaranteed. Thank you very much, Carol, for hosting this once again and sweating out the initial audio stuff. Thank you, Emil, Arfin, Edmund, Gerard, Keith, Mr. MD Shorabali, and NASA. Thank you very much. The slides will be sent to you with the recording, so you will be able to reflect on what we said. And please send us any questions that you may have. I'm very grateful for you listening to us on this session. And thank you very much, Carol. I'm about to leap onto my bike and whirl into the sunset homewards so I can meet up with a few people this evening. Thank you very much, Carol. Cheers. And thank you all. Bye. Thanks, Emil.